Sometimes you have to reinvent the wheel. In my case, that means designing a hubless wheel for my robot. Now, I hear you, dear viewer. Why would I design a new wheel that isn't really new when all these other wheels would do the trick? They all have an axle that goes straight through the middle of the robot. On your typical horse-drawn carriage or automobile, this isn't an issue. Most of the weight of the vehicle sits on top of the wheels, which are usually numerous for stability. In the case of my robot, which only has 2 wheels, putting the weight on top of the pivot point is way less stable than I wanted to deal with again. While my robot no longer has to balance the weight on top, it does have to swing the weight closer to the ground to move. If I were just designing a remote control vehicle, this is not a problem. I am, however, designing a robot that I want to put sensors on. Optical sensors like distance sensors and cameras would not be very effective if their movement is not controlled relative to the world. To solve this issue, I'll be stabilizing the sensor array with more actuators later on. However, I wanted lighter and larger diameter wheels as well. Larger wheels would get me more clearance from the ground and increase mobility, but to make them lighter at the same time, I needed a change of materials. So, if I'm going to 3D print the hub of the wheel anyway, I might as well make the entire system from scratch. Enter the hubless wheel. Well, this is just a 12-inch bike tire, but the goal of this whole exercise is to turn this into a motor-driven wheel with no axle. The profile of the tire was pretty easy to get right, and after a test print with a small section, I was ready to design the entire rim. My printer would not be big enough to print this entire rim in one piece. In fact, I had to print it in 6 pieces. Either way I turned it, I would need to print with a lot of support material. I decided to keep support material out of the inner profile and opted to print each piece as an overhang with support material beneath it. Each of these prints took about 8 hours. When the tire is inflated, all the pieces hold together nicely. I generated a helical gear using a FreeCAD add-on, and I gave it a little friend, too. Putting the teeth at an angle should reduce the backlash and noise from the plastic parts. This part was just small enough to print as one piece. The larger ring gear has 78 teeth and the round gear has 35 teeth. Now that the wheel has teeth, I think we would be better off if its movement were constrained so that it rotates around a central point in space. No, we can't use axles, remember. No, seriously, I already said I wouldn't. Oh, I've got it. Tiny axles. They're like normal axles, but smaller. Also, they have to be placed an exact distance away from each other so that these tiny wheels, like normal wheels but smaller, can travel within this groove. This is a part I call the raceway. It's the interface between the wheels and the rest of the robot. Naturally, I printed this part with walls that were less than 1 millimeter thick. You know, so they would last forever. Turns out they needed to be quite a bit thicker than that. Better print settings, after all, are better print settings. In order for the drive gear to mesh neatly with the ring gear, the motor needs to be mounted the correct distance from the bottom of the rim. To accomplish this, I created a large motor bracket that also holds the outer and inner roller bearings. This part was originally 3 separate parts, but that caused some complications with flexing back and forth, keeping the gear from staying in the right place. Now, the time has come. Final assembly. Here we go with a test of the final assembly for this wheel drive. Here we go. just like that, we can party like it's the year 3000 BCE. If you like this video, you can subscribe to see this wheel become an entire robot. Thanks for watching, and I'll see you next time.